If cylinders were circle versions of prisms, then we can describe a cone as a circle version of a pyramid. And we see a lot of the same similarities between the formulas that we see for a pyramid and that of a cone. It's just we're replacing the concepts with those of circles versus those of regular polygons. So on the right cone, we're going to draw. On the other side, you guys see what is an oblique cone. An oblique cone is if we take what should be at the center, the vertex, and then we just shift it over to the right, and you get this slanted, almost think of a birthday hat that got smashed over to one side. And we, again, don't really deal with oblique in accelerated geometry. We're dealing with just right cones. So let's draw a birthday hat. That's a right cone. And the way we want to do this is to draw, first we can draw the top portion of it, and then the bottom part, think of drawing a pizza slice. And then from there, in a dotted line, you guys can draw the other part of the circle that you actually technically don't see, but know is there. From there, at the center, the vertex on top should fall directly in line with the center of the circle. That's going to then form a right triangle to the edge of the circle. And so we have a few things that we should keep in mind. This is called the radius, as we all know, of the base. The altitude is also called the height. And then we do have a slant height that is incorporated into the picture as well. And that I will highlight. This is the slant height. So this right here being L. Okay, so the lateral area of a right cone equals half the circumference of the base times the slant height. So first, let's take a step back and think of what the formula for the lateral area of a pyramid was. And that was, it was 1/2 perimeter times slant height. So we're gonna write out, remember it came from the area of triangles. So the for a pyramid, it was 1/2 the perimeter times the slant height. If we think about the perimeter of our base here, the perimeter of our base happens to be a circle. So to replace the P with the circumference of a circle, we get 1/2 times 2 pi r times L. We normally don't keep it like that because we notice something happens. 1/2 of 2 is just 1. So the formula that we're going to, and I'll write it over here so we have it, is the lateral area is equal to pi times the radius times the slant height, which we see in yellow over on that side. So let's go ahead and highlight that formula. So just to label some key features, which I know we did above there. The top of the cone, the birthday hat, is called the vertex, similar to what we're used to calling the top of a pyramid. We have the slant height over to the left box, slant height. We have the altitude or the height of the cone being the perpendicular line drawn down to the base. And then we have, I think I was supposed to put these in 2 different boxes, so let's go ahead and do that. Altitude, height. The altitude is a measurement of the height. And then lastly, we have the radius, which you can't really see, so you guys can draw that out if you like. That's the radius. And finally, with the cone being the circle version of a pyramid, and the pyramid held 1/3 less than a prism, then we're going to picture a cone holding 1/3 less than a cylinder. So the formula, therefore, for the volume is 1/3 pi r squared, which is the base, times the height. And that is the volume of our cone. Now we're going to do a few examples on the next page. You're going to be given certain information, and then we're going to have to use what we know about Pythagorean theorem, because we've got a right triangle here, to figure out some of the dimensions that aren't given to us. So first, if we are given that 5 is the radius and 12 is the height, then that's the legs of a right triangle. So 5 squared plus 12 squared, and then solve that to get 169 should be the hypotenuse squared, or L squared. So therefore, L must be 13. This also happens to be another famous Pythagorean triple besides 3, 4, 5, 5, 12, 13 is another famous one. From there, if we were going to calculate lateral area, which I'll write the formula on top for you guys, is pi r L. The total area would be, as you guys would imagine, pi r L plus, you have a single base, pi r squared. And then finally, the volume is a third pi r squared times h. And those are the three formulas we're going to work with. Okay, so let's start with pi r L. When we substitute it in, we're going to have pi times 5 times 13, which does simplify to be 65 pi, keeping everything in terms of pi. We're going to take the 65 pi and then add to it the area of the base, which is pi r squared. So 25 pi plus 65 pi, we get 90 pi. And finally, on our volume calculation, sorry, this kind of got cut off on the side here, a third pi r squared. Let's substitute in our r value of 5 and then our height value of 12. And so when we're simplifying this, we have that it's 25 times, and if you'll notice, the 3 does, and let's do that to simplify things a little bit. 3 does go into 12 4 times. So 4 times 25 is 100 pi. So for this calculation, our volume becomes 100 pi. This time on part B, you'll notice that something else is missing. This time, you're given that r is 8 and the slant height is 17. So if we do 17 squared minus 8 squared, we can figure out what h squared is from there, and that would be 15. So using Pythagorean theorem, we get that that's 15. Lateral area would be pi times r times L. So pi times r would be 8, and then the slant height would be 17. 17 times 8, we get 136 pi. For total area, we're going to take the 136 pi and add to it pi r squared. So pi times 8 squared. 8 squared being 64 pi. If we add the two together, we get a nice even 200 pi for that. And then finally, for our volume calculation, we have that we're going to take a third times pi, and then r would be 8 in this case, and the height of the cone is 15. So if we do the simple calculation that we have here, we do notice that just like the previous problem, 3 goes into 15 5 times. So we can do 8 squared, which is 64, and then 64 times 5, which is 320 pi. Our last calculation, just like the one for our cylinder, we're missing information on the height and the slant height. So this time they give us volume, and we'll say the volume is supposed to be 2 pi here. If we take 2 pi and set it equal to, and let's go ahead and do the work up here. This is the volume that's provided to us. We know that the formula is supposed to be a third pi r squared times h, and r is given to us as rad 2. So I'm going to substitute that in. Let's simplify out what we have on the right. 2 pi is equal to radical 2 quantity squared is just 2. So we have 2 thirds pi times h. If we divide both sides by pi, the pi cancels out, and then we're left with 2 equals 2 thirds h. To isolate h, you're going to multiply both sides by 3 halves. And when you do that, you get h is equal to, by 3 halves, so h would be equal to 3. So once we get the height, now we can figure out what L is. So if I know that r is radical 2 and h is 3, and I'll show the calculation for this, then I can determine L squared is equal to radical 2 squared plus 3 squared. If I square radical 2, I get just 2 plus 9 is 11. So L equals the square root of 11. Okay, for lateral area, let's plug everything in. We have pi radical 2 times radical 11. When we multiply rad 2 times rad 11, we notice that they're both inside rad, so they get married. Radical 22, so we'll leave the pi on the outside, and then radical 22 on the bottom. And then finally, for our total area, we're going to take what we just got for lateral area and add pi r squared because there's a single base. So if we do pi and then radical 2 squared, we have pi radical 22 plus 2 pi, and that's our final answer.